Okay. Hi there. Well, we're going to look at the last section, the last two sections in this chapter 6, and then we'll be ready for a test. And this section deals with what's called a proportion. Now, this is an example I've written here. This is a proportion. And then we'll look at some examples on solving them. But this proportion is made up of, normally we say these are fractions, but we can also say that they're ratios. Ratios or fractions that are equal. I'll just put an equal sign there. So in this case, we have a ratio 2 to 3, or 2/3. We have a ratio 4 to 6, and they represent a proportion. Okay, they're equal to each other. How do I know that 2 to 3 is proportional to 4 to 6? How do I know they're proportional? How can I call this a proportion? How do I know that this ratio is equal to this ratio? And if this ratio is equal to this ratio, we say they're proportional. How do you know if that's true or not? Is this a true statement? Is this ratio proportional to this ratio? And to find that, we use a process called cross products. We're going to find the cross product to determine if this is actually a proportion, if these two ratios are proportional. So we're just kind of learning some new terminology here. Well, to determine if this ratio is proportional to this ratio, we're going to use the cross products to determine if they're proportional. And it's just what it says. You cross and you do the product. So you have to ask yourself, it doesn't matter which one you start with, the 2 times the 6 first, or do you do 3 times 4 first? It doesn't matter. We'll do 2 times 6, which is 12. Does that equal the other cross product, 3 times 4? Yes, it does. Since this is true, we say that these two ratios or fractions are proportional, and this is a proportion, okay, because this is true. The cross product is true. We're also going to use this cross product process to solve for missing variables, in here, okay? So the first thing we're going to do is I'm going to give you some numbers and ask you, are they proportional? So we're going to do the cross product, and then we're going to use the cross product to solve proportions. So our first ones we're going to look at is they're going to determine whether the two pairs of numbers are proportional. So that means that we'll make this into a ratio. Is that true? 4 to 9 and 5 to 12. So we'll go ahead and we're going to do our cross product. 4 times 12 gives me 48. Does that equal 9 times 5? It's called a cross product. Is that true? No. These are not proportional. They are not proportional. They do not form a proportion. Let's look at another set. 1.5 and 2.1, are they proportional with 3.5 and 4.9? We'll go 1.5 over 2.1. Does that equal 3.5 over 4.9? So we set up this proportion. Okay, whenever you have these two fractions with an equal sign, we have a proportion. So I'm going to use the cross product to say, you know, are these proportional? Is this a true statement? I'm going to multiply 1.5 times 4.9. I'm going to use my calculator. So 1.5 times 4.9, 7.35. Does that equal 2.1 times 3.5? I multiply those two, I get 7.35. So this is true. So yes, those are equal, which means that these two numbers are proportional. All right, this set is proportional to that set of numbers. So yes, they are proportional. All right. Okay. Now this one right here, we're going to deal with, well, we can go ahead and set it up. And if nothing else, it's a great review for multiplying fractions. Okay. So I set up my proportion, first number numerator, second number denominator, first numerator, second denominator. And I'm going to determine if they're proportional. Do these represent the same size? So I'm going to cross product, make my cross here, this times this. So I'm going to be taking 4 1/3 times 19 1/2. Does that equal the other cross product? Now remember, product means the answer in multiplication. So we're doing the cross product, we're multiplying. So we've got 6 1/2 times 13. Okay. And now you need to multiply these together. So this is 4 times 3 is 12 plus 1. I'm making them fractions. I took my mixed number and made it a fraction. I'm going to take this 19 times 2 is 38 plus 1 is 39. I will reduce and multiply across. Again, I'm just doing this left-hand side. It's a nice review of multiplying mixed numbers. 3 goes into here once. 3 goes into here 13. So I reduced. Now I'm going to multiply across. 13 times 13 is 169. 1 times 2 is 2. I'm going to leave it like that. I'm going to come over here and multiply those. So 6 times 2 is 12, plus 1 is 13. Always put it over that denominator, just like I put the 13 over the 3 and over the 2, times 13 over 1. I put my integer over 1. I cannot reduce, so I multiply straight across. When I do, 13 times 13 is 169. 2 times 1 is 2. So yes, those pairs of numbers are proportional. So that's how you answer that question. Are they proportional? You set up a fraction, you set up this ratio, and then you do cross products. Product meaning multiply. Okay, all right. Now we're going to use the cross products to solve equations. So I guess I can. Here, we're going to find one of the missing parts so that the proportion is true. So we want to find this missing part so that this is a proportion. So they're telling us it's a proportion, so solve it. So there's only one answer here for this x, unless it's x squared, but we aren't going to deal with that. So to do that, you do the cross product. And this, I'll show you where some people make a mistake. I'm going to take the x times 40, which is 40x. I put the x second. So I just took 40 times x equals 8 times 10, which is 80. Notice that the fractions are gone. For some reason, some people want to put this 80 underneath. They want to keep the fraction idea. But when you do the cross products, it's this times this equals the other cross, and there's no fraction. That's gone. And now you solve it for x using our rules here. So divide by 40 because we want a 1 in front. So x equals, the 10s cancel, 2. X is 2. So if you put the 2 here, you get 80 and 80 for cross products. If you have the 2 on the top, 2 times 40 is 80, 8 times 10 is 80. They need to be equal. So we are solving proportions. Okay, let's look at number 9. We're going to do a cross product. We have an equal sign between them. It's not a times sign, it's an equal sign. It's called a proportion. 12 times m is 12m equals 5 times 36, which is 180, I believe. Let me think. 30, yeah. All right, then we divide by 12. And let me just take, oh, I just don't want to leave you guys astray. So m, 180 divided by 12 is 15. So 12 times 15 should equal 5 times 36. And it does. You get 180 equals 180 when you put it back in to check. Let's solve another proportion. Well, notice how I've been multiplying like the 12 times m first. And I do the multiplication that has the variable with it first, just because I like to have that on my left. So here, the variable's here, so I'm going to multiply that first. 15 times x. It doesn't really matter the order. 9 times 20. And they're equal to each other. No fraction, they're equal. To get the x by itself, I take and divide by 15. So x then is equal to 180 divided by 15. I know that's got to be 12 on the previous problem. Okay. So 9 times 20 is equal to 15 times 12. Hope I haven't lost you, but we're going to do some more. This is pretty much the main idea of these sections. We'll do some story problems, but this right here is the main idea. All right, let's do number 11. What I'm going to do is I'm going to multiply the cross product that has the variable. So I'm going to do that one first. 7 times y is 7y. 5 times 28 is 140. I want to make sure I think I'm right. Oh, 140. Then, because I've done my cross products, they're equal. This product is equal to this product. divide by 7, y equals 20. So I'm saying 20 times 7 will equal 5 times 28. They're proportional. These ratios are proportional. It means they're the same size, they just look different. Okay, let's do another one. 13, I'm going to take the 13 times the x. I'm going to do that product first because that has the variable. That leaves me with 13x. 11 times 5 is 55. So this product equals this product. Divide by 13. I don't believe we're going to get a 55 divided by 13. So what we'll do is we're going to leave it like a fraction. Unless they tell you to make it a mixed number, leave it as a fraction, and that is reduced. So that would be your answer. It's not as pretty as the other ones, but it is an answer. Let's do 13. 7 times x equals 0 times 4. You divide by 7, just in case you didn't know the answer when you first looked at it. 0 divide any number over, or excuse me, 0 over any number is 0. And 0 is an answer as long as the 0 was not in the denominator. If the 0 is in the denominator, there's no solution. It's not a proportion. But you can have a 0 up here. I'm going to erase my little cross thing that I did. So in other words, 0 over 7 is equal to 0 over 4. They're both 0 equals 0. All right. So our x has to be 0 in order for these two to be equal to each other in size. Okay, let's try another one. Here we're going to do the 5 times the x. I always do the cross that has the variable, unless we have variables on both sides, which we will. It's paused. Okay, my God, paused. 5 times x, or x times 5, is 5x. 5 times 4 is 20. So that product equals this product. Then you divide by 5. X equals 4. Okay. I'm hoping you're catching on. It's not meant to be hard. Okay, let's try one that has decimals, and then we'll try one that has fractions, and then we'll go to story problems. And the story problems, I'm just going to go through the ones that are in your homework, so that way you'll have an example of each of those. But there's also one other, no, that's in the next section. Oh, yes. All right. Towards the end of the story problems, there's 3 proportions that we're going to have to kind of practice. But okay, so what we'll do, I guess it doesn't matter which one. We're going to use our calculator either way. We're going to do a cross product. 0.9 times t is 0.9 t. 0.3 times 4.5, 0.3 times 1.35. So this product equals this product. Divide by 0.9. This would be very tedious if you didn't have a calculator. Divided by 0.9. 1.5. Okay, so the decimals are done the same way. They're done the same. But let's look at a fraction. Let's look at, oh, I don't know. Let's look at 17. I think you can get the idea how to do these. So we're going to do a cross product. I'm going to take and multiply these two numbers together, 7/8 times x, and get 7 eighths x. Then I'm going to multiply 2/3 times 1 3/4. I'm going to get that product. So this product is equal to this product. So let's practice this and then practice solving. So I have 7/8 x, 2/3 times, you have to make your mixed number a fraction. 1 times 4 is 4, plus 3 is 7 over 4. And can you reduce? Yes, the 2 reduces with the 4. So I have 7/8 x. 1 times 7 is 7. 3 times 2 is 6. To solve this, I will multiply by 8/7 so that I end up with my 1. I multiply by the reciprocal. Reduce if possible. Over here, I multiplied by 8/7, multiply by 8/7. So again, when you're multiplying with, and you've got these mixed numbers, you do need to make all of them fractions and then just kind of deal with it. So 7 goes into there 1, 7 once. Let's see, 2 goes into there 3. So our x, which is 1x, it looks like it's 1 times 4 is 4, 3 times 1 is 3. Okay, so you have some of those to practice too when you have a few fractions. And mainly this really helps us to review for your final in multiplying and dividing by fractions. And also, it's a good review of solving when you have a fraction there in front. You can multiply by the reciprocal to get rid of it, okay, when you have fractions. All right, so let's look at some story problems. And this is your homework. So in your homework, we're going to pick out some of these. You have to set up, for some reason I got a little wrinkled, sorry about that. You have to set up your own proportion given the story problem. And of course, people hate story problems. So, all right, I got to get a scratch piece of paper because I don't like to see those other story problems as we're doing these. Okay, here we go. All right, we have an English instructor asserted that students' test grades are directly proportional. So there we have our proportional. Now this word does matter, but for our purposes, we're just going to set up ratios. We'll explain this in maybe 9:30 or some of your other classes. Sometimes they're not directly proportional, they're indirectly, but for our purposes, the grades are proportional to the amount of time spent studying. So this goes back to creating a ratio. So we have the grade to the amount of time studying. So we've got a fraction, a ratio here. There's our first sentence. Now let's go ahead to the next sentence. Lisa studies 9 hours for a particular test and gets a score of 75. It's a period there. Now, this sentence tells you your main ratio. So we're going to make our main ratio out of these two numbers in this one sentence. Now, we have 9 hours. So really, it doesn't matter if you put the time studying over the grade, or you take the grade over the time studying. So in these, when you're solving these, you can switch these. What matters is you're consistent, and that'll make sense after when we start to finish this. So I'm going to put 9 hours over a grade of 75. That came from the sentence, and you'll be given one of these sentences in these problems. Sometimes they'll put a comma there and continue on, but most of the time they'll have a period. So you have your first from here. Lisa studies 9 hours and gets a score of 75. Her ratio is 9 to 75. And here, you know, I kind of switched the order here, but like I say, it doesn't matter. Equals, we're setting up a proportion because they're proportional. At this rate, how many hours would she have had to study to get a score of 97? So like I say, it didn't matter if you had grade over time or time over grade. On this side, make sure you stay consistent with what you did over here. That's what matters. So here we've got time over grade. Here you're going to have time over grade. And the grade they want is a 97. How much time to get a 97? I have hours, units, hours across from hours, grade across from grade. That's what's important, is the consistency. The numerators need to match, the denominators need to match in their units. These units need to match these units. So rather than use a question mark, how many hours to get a 97, I'm going to use a variable x. And now it's just like the other page. You cross multiply. So you do a cross product here, they'll be equal to each other, and you solve it. 75 times x equals 9 times 97. 9 times 97, 873. If I didn't have a calculator, I would just leave them apart, but that's okay. Divide by 75. How many hours is she going to have to study to get a 97? All right, now I get, for this, I get 11.64. Well, what do they want? Well, let's look. Round to the nearest hundredth as needed. It stops at 4. There's nothing over there, so that would be how many hours she would have to study. If 9 hours gets you a 75, because they're proportional, 11.64 hours will get you 97, okay, for number 11. So it's getting them set up, and it's trying to get by the anxiety of a story problem. And just look for this sentence where they relate the two together. And that's how you set it up. And then the other one is just, you'll be missing one and you'll be given one on the other side. But these two are related to each other. All right, let's look at another one, number 12. All right, Mary's car will go 261 miles on 14.5 gallons of gasoline in highway driving. So here, they've related the two together. They've related miles to the gallons. There's your first ratio. Those two go together, just like the 9 hours went with the score. So we've got 261 miles over 14.5 gallons. How many gallons will it take to drive 2,290 miles from her house to a friend's house? So we're going to set up our proportion, what was given. And the miles for number A, we have to put it in the numerator because I chose to put the miles in the numerator. So we'll put 2290 miles. Okay. Miles across from miles. How many gallons? That's what we're looking for. So you were given this relationship, this ratio, then you were given one and asked for its corresponding, what it would go with, its corresponding value. Rather than a question mark, I'll just call it X again. So now we cross multiply. I'm going to take the X one first. So 261X. Then I'll multiply these together. 2,290 times 14.5. 332. All right, and then we'll divide by 261. X equals 33,205 divided by 261. This is 127 point, and it's 2 repeating. So do they tell you where they want you to round it off to? Round off to the nearest integer. 7, whenever they say round off to the nearest integer, it's to the ones. Or, you know, which, and that was a 0, you could go to the next one. But here I'm going to round off. So I'm going to keep it as 127. That's the nearest integer. And the units on that are gallons of gas, 127 gallons to go this far. And you expected it to be quite a bit more than the 14.5. Always make sure and ask yourself, does my answer make sense? All right, let's do part B of this one. How far, okay, we still have our original. Okay, that's our basic one. 261 over, let's see if that's still on the screen, 14.5. I've got miles, gallons. So I have to have miles, gallons. How far, so it looks like we're looking for the miles, can the car be driven on 137 gallons? I'm going to put it down here, gallons, gallons. Now how many miles? X. So you had the one that your original, the relationship between these two that was given to you. And then you'll have one missing and you'll be given one. You just need to make sure that the units across from each other are the same. And you cross multiply. This times this, I'm doing this one first, this multiplication because it has a variable. And then we'll take, oh wow, 261 times 137. And you get 35,757. And to solve that, divide by 14.5. Divided by 14.5. So your X is 2,466 miles. All right, which kind of makes sense because, you know, we had 261 gallons, or so, excuse me, we had 127 gallons went this far. So 137 gallons isn't going to go quite as well, it's actually going to go further. So it's going to go further than the 127. So make sure your answer makes sense. And it does. Okay, let's try another one. Let's look at, well, I guess we'll look at 13. A quality control inspector examined 100 light bulbs and found 5 defective. Oh, so you see you have a period there. Okay, you've got this sentence, and in this sentence, they've related the light bulbs inspected to the light bulbs defective. So that will be your basic, your original ratio. At this rate, how many defective bulbs would there be in a lot of 2,000 bulbs? So now one's missing, but you're given another one. So let's go ahead and set up with our original. So we have 100 examined or inspected, and 5 defective. Okay, so the defective are going to go in the denominator. At this rate, how many defective bulbs, at this rate means they're proportional. How many defective bulbs would there be in a lot of 2,000? So they want to know how many are defective if you inspect 2,000. How many would be defective is in the denominator, how many you have, how many you inspected is in the numerator. Okay, perfect. So we have 100 over 5 equals 2,000 over x. Cross multiply and solve it. So we'll make this multiplication first because this is the one involves the variable. And then we'll multiply those two together, and that'll give us 10,000. Now we divide by 100 to get the x by itself. X equals, these zeros cross off with those zeros. 100 over 1, or 100 defective bulbs is what we come up with. All right. So again, you're given a relationship, and then you're given a different, size than these and asked to find the missing part. All right. I just hope they're not giving you too many fits here. Let's look at number 15. In a class of 50 students on average, 8 will be left-handed. I wouldn't even think it would be that high. There's a period there. So we know we have a relationship between the number of students and the number of left-handed. We have that ratio. All right. Now, if 50 are if 8 out of 50 are expected to be left-handed, 42 out of 50 would be right-handed. So we had to kind of see what they want over here. If a class includes 20 lefties, so we're dealing with the lefties, estimate how many students are in the class. So let's go ahead. We've got 50 students and we have 8 lefties. That came from our first sentence. That's the relationship between the two. This is students and this is lefties. So I know over here, whatever was given, we have to match. So it says if a class includes 20 lefties, which means I'm going to put the 20 in the denominator because I chose to put the lefties in the denominator, and I have to stay consistent. Had I had chosen to put the lefties in the numerator, I would have put the 20 in the numerator, but I chose to put the lefties in the denominator. You'll get the same answer either way, as long as you're consistent. They want to know how many students are in the class. So this is what we're looking for, the total students. And so now we'll cross multiply to solve it. And I'm going to do this one first because it's got the variable. 8 times x is 8x. 50 times 20 is 1,000. Now you'll just take 1,000 divided by 8. So you're going to solve it. Divide by 8. X is equal to, I think it's 125, but I want to make sure. Divided by 8, 125 is right. So that you would expect 125 students. So if 50, we have 8 lefties, we know that if we have 20, it's going to be more than 50. And sure enough, it's 125. So I'm hoping that this kind of helps you set these up. You're given a relationship between two numbers, and then you're able to, it equals, and then just make sure you stay consistent. And like I say, it doesn't really matter which one is in the numerator or denominator, as long as over here you stay consistent with what was given and what you would like to find. Okay, all right. So that should get you started at least. There are 3 problems on the last 3 on this assignment that I want to talk to you about. They're a little bit more difficult, but ones that you're going to need to know how to do. This is a proportion, and we're going to solve it for z, and we're going to use the cross product. So I'm going to take 3 times both of those. And here you've got variables with both of them, so it doesn't matter. So I'm going to multiply these two and these two. When I take the 3 times that, z minus 9, you need to have parentheses. So I took 3 times z minus 9. I cross my z's. That's how I tell the difference between my z and my 2. Then we're going to take 1, and I'm going to go ahead and put parentheses even though we really don't need it. I'm going to take the 1 times that. And we'll go through all 3 of these. And now you solve it. And we've looked at these before in a previous section. So we'll take, to solve this, you use the distributive property. 3 times z is 3z. 3 times a negative 9 is a negative 27. And then we'll take 1 times z is z. 1 times 7 is 7. And now we have, there's nothing else you can do here because this doesn't have a z with it. So you can't, they're not like terms. So you can't combine these. You can't combine these because the 7 does not have a z. So all you can do is we need to get the z on one side. It's on 2, we can't have that. And then we need to get the z by itself. I'm going to move the z to the left. So I'm going to get rid of this one on the right. In other words, I want all my z's over here. So to get rid of this, or actually it's moving it, we add its opposite to move it to the other side. Gone, which is what we wanted. You can't have them on both sides. We got rid of the one on the right. So we have 2z's minus 27 equals 7. Then we add 27. Now we're getting the z by itself. We get rid of what's being added or subtracted first, adding the opposite. Okay, 2z equals 34. Adding those two together. Divide by 2 to separate, because you want a 1 in front, so they cancel out. You've got a 1, but you have to divide by 2 over there. So z is equal to 17. Yay. And you can set it back in. 17 minus 9 is 8, times 3 is 24. And 17 plus 7 is 24 times 1. So you get 24 by just putting the z back in and making sure the cross products are equal. So 17 minus 9 times 3, 17 plus 7 times 1. They should be equal, which they are. So let's do another one. Here, I'm going to use the cross product. You know, I think I'm going to copy it over just so it's a wee bit larger here. All right, so then we don't have to, there, I don't know. Had a funny glare on it too. All right, so on this one, we're going to do a cross product, even though my 3/7 is a little high. This times this is equal to this times this. So we're doing our cross product. 7 times y minus 2 is equal to 3 times y plus 9. Okay, and now we solve it. We have to use the distributive property first. So we'll distribute through. 7 times y is 7y. 7 times a minus 2 is a minus 14. 3 times y is 3y. 3 times 9 is 27. So I just use the distributive property. This is a multiplication here and here. And again, the reason I didn't do what was in the parentheses is there's nothing to do in the parentheses when you follow PEMDAS. You cannot add a y plus a 9 without a y. They're not like terms. They stay separate, so you use the distributive property. Now we have to get the y's. We have to get rid of the y's on the right. You know, like I said, you could get rid of the y's on the left. You could subtract 7y. It's up to you. But we're going to go ahead and do minus 3y. And I put it with the other y over here. So that's 0. Great. They're gone on the right-hand side. Over here, because whatever you do here, you have to do on this side, we have 4y. All right. Seems like there's a glare. Maybe it's not so bad. Now we'll add our 2 steps. We're down to 2 steps. Get rid of what's being added or subtracted first. Add its opposite. So that's 0. That's going to be what? 41. Oh, really? I hope I didn't copy something down right. I was really hoping it was going to be a whole number. I'd better check. Sometimes I have little things. Nope, that's right. So add these 2 together, then you divide by 4. There you go. All right. So that's how you'll do those. You use the distributive property, and you have another one to practice with. But I hope that helps going through some of those at the end of the assignment. Well, that is it for these 2 chapters. Next week, we're going to be starting chapter 7, and that's all we're going to do is chapter 7. We're not going to do the 2 chapters. You know, because you have to remember that every week we cover 2 weeks worth of stuff in the regular semester class. So we have 2 weeks of work to do in one. But anyway, so if you have any questions or problems on any of these proportions, try not to make them harder, you know, than they are. Use your calculator, you know, as far as some of these numbers and stuff go, and let me know if you have any questions. All right, bye-bye.